welcome back to Geometry. We are talking about Chapter 3, Section 2, Proof and Perpendicular Lines. So perpendicular lines make a perfect plus sign. That's sort of a lot of P's, isn't it? And so if you're following along in the book, turn to page 136. And we are going to start with a proof. And remember, proofs are these things we do in math, that we prove things by going through logical reasoning. You write down statements and then you write why you were allowed to write it down until you prove what you were supposed to prove. It always helps to draw a drawing too. Okay, so this proof assignment we were given is given angles 5 and 6 are a linear pair, meaning they add up to make a line, and angle 6 and 7 are a linear pair. We are to prove that angle 5 is congruent to angle 7. So whenever you have a proof, don't leave it blank. Kids always want to just leave it blank and go, oh, it's too hard, I'll just miss that one. No, because you can always, some of it is so easy. Always at least do this. So the first thing you write down are your given. So I wrote down these things that were given to me, and the reason why I was allowed to write them down is they're given. So look, I've already got a third of it filled out. The last thing that always goes as your last statement is what you're trying to prove. So you can always write that down. You'll get that right too, because that's what goes there. Now the other things, that's what you got to figure out. Okay, so we have that those are linear pairs, and we can also say, another way of saying something is a linear pair is that it's supplementary. Okay, so we can say angle 5 and angle 6 are supplementary. Angle 6 and angle 7 are supplementary because linear pairs are supplementary. Remember, supplementary, how you remember which one's supplementary, if you cross the S for supplementary, you can make 180. And if you cross the C for complementary, you can make it 90. So that's how you can remember that supplementary angles make a straight line, which are 180 degrees. Complementary ones make 90 degrees. All right, so these are supplementary, and the reason why we can say that is the linear pair postulate. And if you need to go back and look at that, it was in your book on page 827. You don't have to write the page 827. I just want you to go back and see that it's there. And also, I think it's also in the back of your book. 827, that is in the back of your book. But it was also earlier in your book. Okay? Now we can say that 5 and 7 are congruent because of something called the congruent supplements theorem. Now notice that I'm abbreviating. Congruent, that's the abbreviation for congruent, sup for supplements, theor for theorem. You're allowed to abbreviate as much as you want in this stuff. And that theorem is also found in your book. You can find it on page 828. All the postulates and theorems are at the back of your book, but you can only use ones that they've taught you so far. You can't pick one from the back of the book to use. So this was my reason for 1, that's my reason for 2, and that's my reason for 3, and I wrote a proof. Now this is a 2-column proof, and this one's my favorite, but there are other ways of doing proofs. There's one called a paragraph proof, and I'll read you this as a paragraph proof out of your book. I'm not going to bother writing it, but just listen. Because 5 and 6 are a linear pair, the linear pair postulate says that angle 5 and angle 6 are supplementary. The same reasoning shows that 5 and 7 are supplementary. Because 5 and 7 are both supplementary to 6, the congruent supplements theorem says that 5 is congruent to 7. So that's saying that is a paragraph. So that's a new way of writing proofs. Some people like it because it's more conversational. I don't. It's too many words. I like things to be bottom line, cut and dry. get rid of excess words. But some people like it. They like how it's conversational and it helps them think through it. Then there is another one called a flow proof, and here's the same thing. You write your statements in boxes. You write your reason why you're allowed to write your statement underneath. So here's my first box. Angle 5 and angle 6 are a linear pair. Angle 6 and angle 7 are a linear pair. Underneath them I wrote given. Arrow over to the next idea. Angle 5 and 6 are supplementary. Angle 6 and angle 7 are supplementary. The reason why I'm allowed to write this down is the linear pair postulate. And then they both lead to this conclusion. Angle 5 is congruent to angle 7 by the congruent supplement theorem, which is why we're allowed to write that down. So that's a different one, a flow proof. I have had kids who really like that one, because to them, they just like drawing it in little boxes, make all the arrows connect. They like it a lot. I like that one okay, but my favorite is still two column. Yeah, that's how nerdy I am. I have my favorite kind of proof. Alright, so we're going to learn a few more theorems. If you're following along in your book, they're on page 137. And the first one is theorem 3.1. And it says if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. These red lines are the symbol that means that those two angles are the same. Now, my drawing, they might not be, but we'll pretend. Okay, so these two are the same and they make a straight line. So we know that these two lines are perpendicular. If you have two lines that intersect and the two angles make a straight line, and the two angles are the same, it's perpendicular. And that's the symbol for perpendicular. That's angles, that's congruent. Okay, here's one. Theorem 3.2. If two sides of two adjacent acute angles are perpendicular, so this side is perpendicular to that side, and how we know it is that red upside down L. That means perpendicular. So if two sides of two adjacent means next to, two adjacent acute, remember that's sharp, remember it used to mean smart, acute used to mean smart, two adjacent acute angles are perpendicular, then the angles are complementary, meaning that this is 90 degrees. Added together, they make 90 degrees. Okay, and here's our third one. If two lines are perpendicular, they intersect to form four right angles. Each of these angles are 90 degrees. If these are making a perfect plus, which we have to pretend because my drawing's not that good, but if it's making a perfect plus, then each of these angles are right angles, and then later we're going to learn that all right angles are congruent. That they'll all be the same, they're all 90. Alright, there's a couple of more proofs in there. Your book spends time proving theorems. I want you to read those, but I don't really care if you learn how to prove theorems and postulates. I want you to be able to prove things like this, that you're given something and you're trying to prove something else. That's the kind I want you to be able to master. We'll leave proving the theorems and postulates to the math majors, and if you become a math major, then you can do it. Alright, so not bad, and I'll come back and we'll talk about parallel lines. Math is fun.